Weigh out 5 millimole of Transccinamic Acid and transfer it to a 25 round bottom flask. Add 4 milliliters of dichloromethane to the flask. Add a magnetic stir bar, then set up a reflux or a stirring plate. The bottom of the flask should be about 1 centimeter above the surface of the hot plate. Carefully measure and add 2.7 milliliters of 10% volume by volume bromine and dichloromethane to the reaction flask. Turn on the stirring mechanism, the water to the condenser, and the heat. The reaction flask should be heated to about 50 degrees centigrade. Pure dichloromethane boils at around 40 degrees centigrade, so gentle reflux may occur. Allow the reaction to heat up for 35 minutes. At the end of the reaction period, add a drop or two of cyclohexene to destroy any unreacted bromine. Cool the reaction mixture to room temperature. Then cool it in an ice bath for 10 minutes to complete crystallization. Collect the crystals via vacuum filtration. Wash crystals with 3 2 ml portions of cold dichloromethane. Recrystallize the product by transferring to a 25 or 50 ml Erlenmeyer flask and adding 5 ml of 50% ethanol. Gently heat to boiling. If the crystals do not dissolve, add an additional 0.5 ml portions until the dissolution is complete. Allow the flask to cool down to room temperature. Then ice for 10 minutes before performing a final vacuum filtration, washing the crystals with 3 to 4 ml cold solvent. After filtering a recrystallized product and letting it dry overnight in the oven, we'll record its mass. We will predict the stereochemistry of the products in this reaction, then test for prediction by taking the melting point of the product. Each set of enantiomers has a very different melting point, so the product's form should be readily apparent. We'll start by taking some of the sample into a capillary tube. Then we'll drop the capillary tube into a larger tube to ensure it's packed at the bottom. After placing the capillary tube into the melt temp, we'll record the temperature range at which our product melted. In this case, the melting range was 202 to 204 degrees centigrade, which coincides with our desired enantiomer.